All right, let's take a look at section 8.3, where we're going to be talking about absolute value inequalities, equations and inequalities. First thing we want to mention is that when we say absolute value, what we're really talking about is the distance from zero. So let's say, for example, I say that the absolute value of a number is equal to 4. What that means is that I can be 4 units away from zero in the positive direction, but I can also be 4 units away from zero in the negative direction. So possibilities for my x would be both positive 4 and negative 4 because they are both 4 units away. So here's the takeaway. When we do absolute value equations, you have to have two answers. You have to go in both the positive direction and the negative direction. All right, so you've got 3 different cases. Okay, so case 1 is when you have an absolute value equal to a number. Once again, you can go in the positive direction or you can go in the negative direction. This takes care of the positive direction. This takes care of the negative direction. The answer is usually going to be 2 numbers, right? A set, okay? So that's when it's equal. When it's greater than or equal to, it's going to be this kind of situation. It's going to be a compound inequality. So we could either be going in this direction, the positive direction, or we could be going in the negative direction like this, okay? So solution is going to be an interval, union, another interval. All right. When you have greater than, you're going to write it 2 different times. You're going to write it greater than the positive or less than the negative. So you reverse the symbol, you reverse the sign. Reverse the symbol, reverse the sign. Okay, and the next one, case 3, is when it's less than or equal to. When it's less than or equal to, this is an and situation. Okay, and I will show you why this works, why an and situation, intersection, turns into this. Okay, let me get some, yeah, here we go. So before we do this, I want to show you why an and situation turns into a 3-part inequality. So let's suppose I have x is greater than or equal to 2 and x is less than or equal to 5. Okay. So what I'm going to do is I'm going to show you 2 different ways. First way is I'm going to do the 3 number lines. So the first one, we've got 2, and we're going in this direction. And the second one, we've got 5, and we're going in this direction. And it's and, so it's the overlap, and is the overlap. So it would be between 2 and 5. Well, if we write this as an inequality, we usually write it as 2 is less than or equal to x is less than or equal to 5. Okay, we usually write it with the x in between these 2 numbers, smaller number on the left, bigger number on the right. I'm also going to show you, without doing the number line, why it works as well. Okay, so we have x is greater than or equal to 2, and x is less than or equal to 5. What I'm going to do is I am going to rewrite this with the 2 on the left. So I have 2, got to switch, reverse the sign, is less than or equal to x, and x is less than or equal to 5. Do you see how the x is between the 2 and the 5? So 2 is less than or equal to x, and x is less than or equal to 5. So when we have this situation, it's really just kind of another way of saying the intersection or and. So when we look at this previous slide here, this might make a little more sense why we use the, not the union, sorry, the intersection. When we do less than, it's going to be between those two numbers. And when we do greater than, it's going to be the union. Union. Okay. So either way you look at it, right, we have to have a positive k and we have to have a negative k. When it's less than, we just stick that, whatever the absolute value is, in the middle. Okay. Absolute value refers to the distance from the origin. You are always going to have two different parts, always. First thing, when we drop the absolute value symbol, we always have to have two, one positive, one negative, and you have to solve them separately. 3x is equal to 15. You cannot, there is no shortcut on this. I wish there was, there is not. So for those of you that remember that you need two answers, most of the time what students do wrong is they completely forget the negative, or they think the answer is plus or minus 5, which clearly it is not. It is positive 5 and negative 7/3. Okay, we can write it in set notation like that. Okay, remember, you have to solve it twice, once with the positive, once with the negative.